one and all. Today I'm explaining about the topic of probability of event containing sample events. Myself, K. Vijay Kumar. I'm from Mechanical Engineering. Introduction to probability. Probability is a branch of mathematics that deals with the level likelihood of events occurring with quantities or uncertainty in various aspects of life and science. Understanding probability is essential for making informed decisions based on potential outcomes. What is an event? An event is a specific outcome or a set of outcomes from a random experiment. Events can be simple or compound depending on the number of outcomes they en- encompass. For example, rolling a die can be result in multiple events based on the number shown. Is an experiment, the spinner is conditioned all the possible outcomes 2, 6, 4, 3, 8. There is a circle of the example. Then this is called event. Understanding simple events, probability of simple events, probability of event occurring is equal to number of favorable outcomes by total number of outcomes. P of A equal to N of A by N of S. It's the formula of probability of simple events. A simple event is a single outcome of a probability experiment. For instance, getting a 3 when rolling a single die represents a simple event. Simple events are building blocks for defining more complex events. For instance, getting 2 when rolling a single die represents a simple event. Simple event is a single outcome of probability of 2 experiments and simple events. There is a simple event for even building blocks for the defining more complex events. Compound event, probability of compound, the water compound. There are two types of compound. One dependent event, and next one is that not event. Involves the two or more events in which the outcome of one event does not affect the outcome of any other events. Roll dice, conflict problems with replacement. P of A and P of B equal to P of A into P of B. The compound event consists of two or more sample events combined. Example of compound events include rolling and even our drawing a hat from a deck of cards. These events can be independent or dependent on each other. Example space. Sample space is a set of possible outcomes of a probability equation. For a single die roll, sample space contains the numbers 1, 2, 3, 6. There is a table for sample space. Understanding the sample space is crucial for calculating the probability of events. 1, 1, 1, 2. And so on the 1 comma 6 and 2 2 comma 1 2 1 2 and so on 2 comma 6 3 comma 1 3 comma 2 and so on 3 comma 6 4 comma 1 4 comma 2 and so on 4 comma 6. And fifth one is 5 comma 1 5 comma 2 and so on 5 comma 6 and sixth one is 6 comma 1 6 comma 2 and so on 6 comma 6. Calculating probability. The probability of an event is calculated by dividing the number of favorable outcomes by total number of possible outcomes. Probability rule to find the probability of random multiply to probabilities of the branches. First loop, second loop, outcomes calculations. Head, tails, tails, head, tails, tails. For example, the probability of rolling a 3 on a die is 1 out of 2. For example, the probability of rolling on a 2 is a die 2 out of 3. This can be expressed mathematically as the event number of favorable outcomes by total outcomes. Example outcome. Examples of probability calculation. If you flip a coin, the sample space is head tails. The probability of landing on head is 1 out of 2 or 0.5. Similarly, drawing an ace from a standard deck has a probability of 4 out of 52. Less than half is equal to head, then head, tail, and head, tail, tail, head. Probability is equal to 1 by 8, 1 by 8, 2 by 8, and 3 by 8, and 4 by 8. When you do multiple coin tosses, it requires separate probability values to get probability of specific outcomes. If you flip a coin, the sample space heads, tails, heads. The probability of landing in heads is 1 out of 2 and 0 or 0.5. Similarly, drawing an ace from a standard deck has a probability 4 out of 52. The role of independent and dependent events. Independent events do not affect or each other's probability, such as rolling dice. Dependent events are influenced by previous outcomes like drawing cards without replacements. Understanding these type of events is essential for accurate probability calculations. Independent events. Independent events are events which are not affected by the occurrence of others. For example, we roll a dice to the outcome of first roll and second roll have no effect each other. They are independent. If two events are independent, P of A and B is equal to P of A into P of B. For example, when we roll a dice, the probability of getting a 6 is 1 by 6. The probability of getting a 6 is 1 by 6, 1 by 6 into 1 by 6, equal to 1 by 6. Next, real world application. Probability concepts are widely applied in fields like finance, healthcare, and engineering. For instance, companies use probability to assess risk, determine premiums. Understanding probability helps in making predictions and informed decisions in uncertain environments. Conclusion: the probability of event is fundamentally linked to its simple events. Mastering probability enhances analytical skills and decision making ability. A solid grasp of these concepts is crucial for both academic and practical applications. Mastering probability of analytical skills and decision making abilities. Probability of simple events equals probability of event occurring equal to number of favorable outcomes by total number of outcomes. P of A equal to N of A by N of S. What is the event? The event is a specific outcome or a set of outcomes, a random experiment. To the right, rolling a dice can result in multiple based on numbers shown. Examples in the table 2, 6, 4, 3, 8, 5. Probability of event occurring equal to number of favorable outcomes by total number of outcomes. P of A is equal to N of A by N of S. Compound events. A compound event consists of two or more simple events combined. Examples of compound events include rolling an even number of throwing a hat from a deck of cards. These events can be independent or dependent on each other. When involves two or more events in which the outcome of any event does not affect the outcome of any other. For example, Rolls Royce quality problems with P of A and P equal to P of A into P of B. Samples to the sign. Which set of all the possible outcomes of for a single die roll. Sample space contains the number of 1, 2, 3, 4, 5, 6. Understanding the sample space is crucial for calculating the probability of events. Calculating probability. The probability of an event is calculated dividing the number of favorable outcomes by total number of possible outcomes. For example, the probability of rolling a 3 on a die is 1 out of 6. This can be expressed mathematically as the event number of favorable outcomes, total outcomes. Examples of probability calculation. If I coin the sample places the head and tail, the probability of heads is 1 out of 2 or 0.5. Similarly, drawing an IS from a standard deck has probability 4 out of 50. When you do multiple coin tosses, multiplies separated probability values to get probability of specific outcomes. For each toss, probability is the number of favorable outcomes divided by the total number of outcomes. Today, ignition. The role of independent and dependent events. Independent events do not affect each other probability such as rolling dice. Independent events which are not affected by the occurrence of other events. For example, if we roll a die twice the outcome of the first roll and second roll have no effect on each other. They are independent. If two events are independent, then P of A and B is equal to P of A into P of B. When we roll a dice, the twice probability of getting 6 is 1 by 6. The probability of getting 6 is equal to 1 by 36. If events are independent, then rolling friction. The applications like healthcare, financial, and engineering through a dice. For instance, insurance companies are using probability to ask risk and determine premiums. Understanding probability helps you in making predictions and informed decisions in uncertain environments. To know the probability of an event is fundamentally linked to its simple events. Mastering probability enhances analytical skills and decision making ability. The solid grasp of these concepts is crucial for both academic and practical applications. Probability of simple events, number of favorable outcomes by total number of outcomes. P of A is equal to N of A by N of S. The reason event is fundamentally linked to its simple events. Passing probability enhances analytical skills and decision-making abilities. So solving class for these concepts is crucial for both academic and practical fields. Probability of single events. Probability of an event occurring is equal to. Thank you.